welcome back to another video of Hut and Techie. So from this video we are starting a new series called as Ultrasound Physics Instrumentation series called as UPS series. So welcome to the UPS series of Hut and Techie. So those who are preparing for the ultrasound physics examination like ARDMS examination, RCS examination or other board examination, I think this video will be very helpful for you guys. So we are doing in as like different parts. So this first part of our video, part 1, will be covering like what is meant by the ultrasound and what are the interaction of the ultrasound with the tissues, what is the velocity of ultrasound or wavelength, what are the different properties, and what are the different type of probes, ultrasound probes, and what is meant by like piezoelectric effect. These are the basic things I know, like you guys know about this all. But even though when we are going to the main topics, before going to that we have to know like what are the basic concepts which are there in the ultrasound physics. So that are the things which we are going to cover this video. So keep watching the video. So you guys can see this is the electromagnetic spectrum. So in this electromagnetic spectrum we are arranging the waveforms based upon their wavelength and the frequencies. So in this there are some waves which we are using for the medical imaging purposes, right? So this like X-rays, ultrasound. So these are the different type of waves which we are using for the diagnostic medical purposes, like for the imaging studies, for the diagnosis or detection of the diseases, we are using this waveforms. So as we know, like when we are going to some X-ray or radiology related testing, and it will be written it as precaution, like we should be caution when we are around as a patient or a bystander or a staff, hospital staff or whoever it is. When we are working in X-ray, we have to use the lead aprons or the other some personal protective equipments to prevent the radiation. As a patient we don't have any options, we have to face the X-ray, right? So we can see some caution symbols which is written in the X-ray and other radiology rooms, right? So some waves like X-ray waves will produce some radiation, so it is very harmful for our biological cells. But when we are taking an ultrasound, it is a special kind of wave which don't have any kind of like side effects. Like for some patients who are coming for the tests like ultrasound or something, they will ask us, right, is there any radiation is there for the test and it is harmful for me or not? So that will be the first questions they will be like asking. So ultrasound won't have any kind of like side effects, and so ultrasound is a type of wave and it is a longitudinal wave. So longitudinal wave will have like different area of compression and refractions will be there. So this ultrasound will be moved in a longitudinal way, so it will be moved through a single direction. So that is we are actually mainly meant by. So we know like the audible sound with it will be in a range of 20 hertz to 20 kilohertz. So this will be our audible range. But ultrasound waves will produce some sound waves, but that won't be like audible for us. So it will be in a range of 2 to 20 megahertz, 2 to 20 megahertz. So when we are seeing in a ultrasound machine, there will be like different probes which like these are the things which we are using for the scanning, and from these things only the ultrasound is getting produced. Okay, so this will have the frequency of 2 to 20 megahertz. So we cannot hear like when the ultrasound is passing or something, we cannot hear the ultrasound. So that is the reason behind it. So this is an ultrasound equipment. So like each scan, like we are going to a cardiac scan or ultrasound scan, all the things which we are doing will be the basic things, and only the thing will be like for each organs we are using different probes, different type of probes are there that I'll explain in the upcoming sections. And we have to know like this probe will have different shape and sizes, because it will be using for the different scans. Okay, but for all this, the measurements and the things, whatever the calculations which we are doing, everything will be the same, and everything will have only one basics, that is called ultrasound. So we have to know what is meant by the ultrasound physics thoroughly before we are scanning. Okay, or those who are working in ultrasound field also, like we have to be like continuously like we have to acquire knowledge regarding the ultrasound physics in order to acquire a good images and all. Okay, so in this diagram we can see this is a waveform of a like sound wave. Sound wave, it will have like two axes we are depicted. So basic thing, first two things we are going to learn is the frequency and the wavelength. Okay, so as you know, like wavelength is the distance traveled by a wave, and frequency will be the amplitude of that. Okay, so this frequency and wavelength, these are the two basic first things like we are going to learn. So there are like different terms are there in ultrasound physics. So in the as a beginner it will be very confused for you. So this we have to keep it in your mind. First two words, frequency, then wavelength. Whenever we are taking a frequency and a wavelength, this is inversely proportional. So you can see this formula, and this is the speed of ultrasound in a tissue. So that is around 1540, and when the frequencies increases, the wavelength decreases. When the frequencies decreases, the wavelength increases. So this is thing we are calling as inversely proportional. Inversely proportional means when one thing is increasing and the another thing will be decreases. If it is a directly proportional means if one thing is increases, then another thing it should be also increases. So this are the thing. And next we are going to see like how the ultrasound is produced from this small probe. Okay, so we have discussed about the ultrasound. We have to know the features of the ultrasound, but before that we have to know like how it is generating. Okay, so we have some crystals known as piezoelectric crystals which will be inside this probe. Okay, so this will be like mostly made up of lead, zirconite, titranate, or some other materials. So these materials like these crystals, when we are applying some electrical signals, this will cause some oscillation and it will change its shape and it produces the ultrasound. So this is the basic thing which is happening. So in this ultrasound machine, this is a probe. So whenever we are giving the electricity, so the machines will be plugged into the electrical system, right? So whenever we are plugging it, and this will cause some changes in the crystals shape in this small probe. So this will produce the ultrasound. As I told you, we cannot see the ultrasound. There are different type of probes are there, as I told you. So these are the different shape of the probes, and but this when we are taking a probe and whenever we are taking a cross section of the probe, when we are opening it, this basics will be the same for all. Only the size and the arrangement of the piezoelectric crystals will be different in different probes. That's it. So as you guys can see, these are the parts of the ultrasound probe. So it will have a insulation, acoustic insulation, and some cable which is helped to deliver the electrical energy to the probe, and it will have a matching layer, backing case material, and some ultrasound like piezoelectric crystal layer will be there inside, and this insulation will be helping to prevent the electrical signal shock between the operator and the probe. And there will be matching layer, backing layer. So these features I'll be giving here in the screen. So regarding this we will explain in the next video. So this is just a basic, and the speed of ultrasound in a tissue is around 1540. So whenever we are taking a muscle, tendon or ligament, or compared to the tissue, ultrasound will have more like more it can able to pass through a tissue very fastly compared to the air. So it needs a medium for the transmission. So the medium we are using a gel. So whenever you're going for a ultrasound scan, or whenever we are doing a scan in a patient, we have to use some gel. We have to put it in the probe, and we have to do the scanning in order to get a proper image, because for transmission it needs a gel. Okay, it needs some things for the transmission. So in the upcoming videos we will be focusing on some another topics. So keep watching our UPI series. So any doubts, please do comment in the comment box. If you have any suggestions, please do a comment so I can also go through that. Thank you so much.